I've cleaned my whiteboard, and now it's time for part 3 of complex numbers. Today we're going to talk about multiplying and dividing them, and also something called the conjugate. Okay, so if I have 1 plus 2i, and I'm multiplying that by 3 plus 4i, what will I get? Well, remember how Mr. Lawrence said that radicals behave as variables. So let's go ahead and see what this is the same thing as. It's going to be, you can FOIL it, right? 1 times 3 is 3. 1 times 4 is 4 rad 3. 2 rad 3. It's going to be 6 rad 3. And then 2 rad 3 times 4 rad 3 is going to be 8 times 3, which is 24, which is then going to give us 27 plus 10 rad 3. It's the same idea with this. It's going to be 1 times 3, 3, plus 1 times 4i, 4i. 2 times I times 3, it's going to be 6i. 2i times 4i is going to be 8i squared, which is then going to be 3 plus 10i minus 8, right? Because I squared is -1 as we defined it. So this is going to be -5 plus 10i. That's what we're going to get out of it. Okay? So, what is then 3 plus 5i times 2 plus 7i? Let's multiply it through. It's going to be 6 plus 21i plus 6, 21i, 10i. 5 times 7 is going to be 35, and then we're subtracting that because of the I squared, and then we get -29 plus 31i. Okay? Right? I believe, yes, this is correct. So, you can see how easily my whiteboard gets dirty. So now, what about dividing? What about I plus 1, or 1 plus I? Always write it like this. It'll make everything easier. Divide by 1 minus I. Well, let's talk about something called the conjugate. If z, it's a variable, z is some a plus bi, it's a complex number, then we say z bar, we put a little bar above it. It's going to be a minus bi. Basically meaning if z is 1 minus I, then z bar is 1 plus I. What can we do with this then? Well, if you remember correctly, a plus bi times a minus bi is a squared plus b squared, right? Both of these are real numbers, right? They're both real numbers. Both a and b are real numbers. Therefore, this thing is also a real number. It's not an imaginary number. It's not a complex number. It's a real number. But what is a minus bi to a plus bi? Well, a plus bi is z, right? And a minus bi is z bar. Is a squared plus b squared. Okay. So let's multiply this. So what's the problem here? It's the denominator, isn't it? We want to get rid of that. We want to make that a real number so that we can divide it normally. So let me write this bigger. 1 plus I over 1 minus I. You multiply this by this conjugate. So if this is z, then I'm going to multiply by 1 plus I. But we can't just multiply the denominator by 1 plus I. We also have to multiply the numerator by 1 plus I. This is the same thing as multiplying by 1. And remember, this right here is z bar. Okay? So this is going to be 1 plus I times 1 plus I divided by 1 minus I times 1 plus I. This right here brings us to the conclusion of 1 minus I times 1 plus I. We already know what that is. It's a squared plus b squared, which is just going to be 2. Because a in this case is 1, b in this case is negative 1. It means a squared plus b squared is 1 squared plus minus 1 squared. It's 2. Then on top, you're going to get you're going to get 1 plus I, and then it's going to be 2I. I can't even. This just gives you I. Okay? It just gives you I, because you can cancel out those 2's. Just gives you I. Right? Because 1 plus I times 1 plus I is 2I. 1 times 1, I times I, minus 1, cancel out. 1 times I times 1, 2I. There we go. Okay? Basically meaning 1 plus I on 1 minus I is just I. It's kind of weird, isn't it? So let's go ahead and do another problem. What is 1 plus I times 2 plus I divided by 1, 2 plus I, 1 plus I and times 1 plus 2I. For example, you don't actually need to multiply the top and the bottom because you can cancel those out. Okay? So this is just 2 plus I on 1 plus 2I. Multiply by the conjugate on that, which is going to be 1 minus 2I. 1 minus 2I. You get 1 squared plus 2 squared on the bottom, which is going to be 5. Then on the top, you get 2 plus I times 1 minus 2I. It's going to give you 2, and then you're adding on to that 2. So it's going to be 4, and then you're doing 2 minus 4I, and then plus I minus 3I on 5. If you have any doubts about that, you can go ahead and multiply it. I'm going to go ahead and multiply it through fully right now. 2 times 1, 2. 2 times minus 2i, it's going to be minus 4i. Then I times 1 is going to be plus I. And then I times minus 2i is going to be plus 2, which is then 4 minus 3i. Dividing that by 5, you can distribute that, so you get 4 on 5 minus 3/5 I. Okay? So if you see something that's similar on the numerator and on the denominator, you can probably cancel it out, unless you're adding. So you cannot cancel out 1 plus I on 2 plus I. You cannot cancel out the i's. Doesn't work like that. But if you have 1 plus I times 2 plus I on 2 plus I times 1 minus I, you can cancel out those 2 plus i's. And then you're going to get I out as a result. So let's go ahead and get to some problem questions. So, example, what is 2i plus 3 times 4i plus 5? What is 1 minus 3i on 2 minus 4i? Number 3, what is 1 plus 4i times 1 minus 3i divided by 2 plus I? Note that you cannot cancel anything out in this. Number 4, what is 1 minus 2i times 2 plus 3i divided by 2 plus 3i times 3 minus 2i? Okay? These, I'm doing 4 this time, but I usually don't. So, yep, there you go.